This is an example where a facility consumes natural gas, and it consumes this natural gas at this exorbitant amount of gas. It consumes 86,000 gigajoules per year at natural gas, and that natural gas costs $10 per gigajoule. And it facilitates, it generates 6 million kilowatt hours per year. This is a good thing of electrical energy. And it also makes 31,000 gigajoules of useful heat energy. Now, the electricity generated, this electricity that it makes here, it offsets the electricity that it would have had to be purchased, and it would have had to be purchased at this amount, 10 cents per kilowatt hour of electricity used, or kilowatt times hour of electricity used. Remember, that is the electrical rate, not the power consumption. Now, if the CHP system can use some of the thermal energy, if it can recover it here, if we can recover this useful thermal energy, we can offset this not so good gas-fired boiler. This gas-fired boiler is only 80% efficient, and that fuel, that natural gas, again, costs, remember, $10 per gigajoule. This is a huge facility. This example problem is from the AEE, the Association of Energy Engineers, from the CEM, Certified Energy Manager Certification Prep course from 2017. It's a fantastic question that shows you that instead of running this gas-fired boiler, what would be the reduction in annual energy costs if we offset this gas-fired boiler? So in a question like this, we're looking for this word of offset. We are offsetting a gas-fired boiler with this CHP system, so we don't have to spend that $10 per gigajoule on that gas and that inefficient gas-fired boiler anymore. What is the effect of this CHP system? So in this, I would do some basic economics, and I would say, what is the net energy savings? I would calculate the net energy savings, and then I can apply some cost to that, or I can even apply cost to it as I'm doing the energy savings. So the net or the net dollar savings, right? The dollar savings per energy of the energy that we're paying for. We're paying for electricity, and so we're going to save some of the electricity cost that would have been purchased at 10 cents per kilowatt hour. And then I'm going to have some recovered thermal. If I can recover this thermal energy, then I will save some money. Minus the gas that I consumed to put in this CHP system, even though it's making us electricity savings and it's making us thermal savings, it did consume some gas. All right, so I'm going to, this is the cost of the gas consumed, right? So it's the cost of the gas consumed, it's the recovered thermal in dollars, and the electrical savings in dollars. So first, I'm going to calculate those electrical savings. So this is sort of the equation that I'm going to be working from, and I will leave it in some, I will kind of color code it accordingly. So our electricity savings. So it's actually an offset, right? It's also an offset from that 10 cents per kilowatt hour that I was going to be spending. It's going to be the amount of electricity that I would have bought, which is in kilowatt hour per year, times the cost of that electricity. And instead, remember, I'm going to be consuming natural gas in order to start up this CHP system. I'm not going to be buying this electricity anymore. So that's going to be 6 million kilowatt hours per year, times the 10 cents that you pay per kilowatt hour, which would save $600,000 per year by offsetting that electrical utility that you would have been purchasing before. Now, we can get into a debate about clean energy, low carbon energy, how clean was the grid that you were buying electricity from, and that is a very valid and reasonable debate to go into. Especially right now with heading towards a lower carbon future. But in this case, it's the CHP system is offsetting electrical energy, and it's also going to recover some thermal as we go. So the recovered thermal energy is also worth considering, because you literally don't have to or sorry, this will be what you don't have to pay for anymore, right? The CHP system is going to be a topping cycle, because it's going to make the electricity first by driving a turbine and hooking that up to a generator, and then it's going to recover that heat from that topping cycle, that topping CHP cycle. And of course, that heat would have had a cost, and it has an efficiency as well. So that's our 31,000 gigajoules. And that the cost of that is $10 per gigajoule. And it has an efficiency of 80%. It's saving us $387,500 per year. So I'm no longer going to spend $600,000 in electricity. I'm no longer going to spend $387,500 on the boiler. But it is going to cost us some gas to run this CHP. So of course we have to have the cost of gas consumed. And that would be the amount. And it's not an insignificant amount. And it would be not an insignificant carbon footprint as well, times the cost. So it is 86,000 gigajoules per year in order to receive these savings. The cost, of course, it's the same whether you were, a CHP system or you were running a boiler. It's still $10 per gigajoule in this example, which of course would be 860,000 let's see, dollars per year. So then our net energy savings, of course. So therefore our net savings would be, oops. Therefore, net savings is going to be my $600,000, plus I'm going to save $387,500 minus it's going to cost me to run this CHP system $127,500 per year. This is all per year. So the net savings is $127,500 per year. Are you still burning fossil fuels? Yes. You are just gaining the efficiency of being able to make your own electricity, recover some of your own thermal energy, in order to pay for this topping cycle CHP facility, to do both of those for you. And the cost is going to save you $127,500 a year, not taking into account carbon pricing, and the effect to greenhouse gases and everything political of nature and goals wise in terms of reducing net carbon. But this is how a business case for CHP facilities would work.